This is the physical footprint of the modern AI revolution. Inside these server farms, the hum of hardware represents a massive, non-stop demand for energy that the digital world has never seen before. While typical commercial buildings experience peaks and valleys in energy use, AI data centers run differently. Because training and inference protocols require high utilization around the clock, these facilities draw a massive, unchanging load every hour of the year. This chart shows the projected impact of that constant draw. The International Energy Agency expects global data center electricity consumption to roughly double by 2030, reaching approximately 945 terawatt-hours. As compute requirements scale, the availability of bulk electricity is emerging as a primary binding constraint on growth. Without a massive power supply, the most advanced software in the world has nowhere to run. Meeting that demand requires a massive expansion of public infrastructure. But connecting a server farm to the existing electrical grid is no longer a simple matter of paperwork. Tech developers frequently have the capital and the chips ready to go, yet they find themselves physically locked out of the power they need to begin operations. They're hitting the interconnection queue. In many major markets, the waiting list for a new high-capacity grid connection stretches for several years, as utilities struggle to build the new transmission lines required to carry the load. For a company racing to deploy AI capacity, this creates a significant business problem. A multi-year wait for a power connection is a multi-year delay in generating revenue from their investment. This sluggish public infrastructure has created a high-value opportunity for any private entity capable of delivering immense amounts of power on a much shorter timeline. To move faster, developers are bypassing the public grid entirely, building dedicated power plants on site, a strategy known as behind-the-meter generation. While tech companies invest heavily in renewables, wind and solar installations alone struggle to meet the specific requirements of a modern AI site. This graph illustrates why. An AI chip's energy demand is unrelenting, creating a perfectly flat 24-hour load profile. But renewables create supply gaps. Solar peaks and vanishes, while wind can drop for days, leaving the data center's flat demand unsupported. While renewable growth remains critical, these facilities require a reliable source of firm power that can be dispatched immediately to keep the servers running when the sun goes down. Natural gas turbines have become the specific industrial tool used to fill this role. These machines provide highly dispatchable, constant power. They can be ramped up on demand to match the unyielding load profile of AI compute clusters. Because these turbines can be sited directly next to the data center, they solve the timing problem by avoiding the transmission grid bottleneck entirely. The volume of this shift is massive. Equipment maker Baker Hughes booked 2.7 gigawatts of turbine orders in a single quarter of 2026, driven largely by this demand for on-site power. For many developers, heavy mechanical engineering is currently the most viable path to scaling up infrastructure while the public grid remains locked. This massive rush for on-site generation has moved the bottleneck further down the chain. The tech industry has ordered equipment in such high volumes that the supply chain is beginning to strain. The primary constraint on AI expansion is no longer found in software code or the digital grid. It has shifted to the physical factory floor where these massive turbines are forged. Lead times for new turbines now stretch several years into the future. For developers, placing an order today is no longer a guarantee that they can turn on their power tomorrow. The digital expansion of artificial intelligence is now being gated by the physical realities of heavy industry. Legacy industrial companies are now racing to expand their manufacturing capacity by 2028, aiming to capture the surge in tech-driven demand. The strategic focus for these energy giants has shifted toward the value of the delivery timeline itself. In a market defined by delays, the ability to shorten the path to operational power is a premium service. These systems are engineered to reach full capacity with high reliability, providing the kinetic intensity required to sustain the digital economy. Tech companies are increasingly prioritizing speed to power, paying a premium to any provider who can shave months off a project schedule and get their training models running sooner. The ultimate victors in the AI race will not just be the companies with the smartest software, but those that can secure the heavy industrial iron needed to turn it on.